Hello, everyone. I'm excited today to talk about modern data quality and sort of the challenges that we've all experienced over the years with traditional data quality programs. What we hear a lot, and it's become kind of the norm at this point, it's a common statistic that 80% of our time as data citizens has become cleaning and wrangling and prepping and preparing for data. And we care so much because we need to prepare the data for downstream use, and we want the data to be accurate and ready for those great analytics that our business loves to consume and see. So there's this looming question in my mind, though, of why do we never solve it? How come we never get there? What can be done? Can anything be done, or are we just always going to have to accept this reality? And I believe that there can be, and that we've been on a mission to achieve this for quite some time. And I want to go piece by piece today and kind of break down why that's happening and what we can do to solve for it, and delineate between what was done in the past, i.e. traditional data quality, versus a modern and predictive data quality approach. So I'm Kirk Haslbeck, excited to be speaking on behalf of Collibra Product and DQ Engineering. I've spent the last several years focused on just this space, and delighted to share kind of all the problems and challenges and futuristic opportunities that we have to achieve in this space. The first topic I think we have to touch on and kind of bring it to light is the diminishing returns of static rules. It's known in all other areas, but we don't think about it that much with data testing and data accuracy and trust about why there would be diminishing returns on static rules. But if we were to go into the machine learning culture or try to build models with data science, there is a known fact that if we release a model into the wild, into production, it will diminish in value within 6 months. That means the accuracy, the precision of the model, the things that it tells us to do or makes suggestions to us will become less valuable. It's usually because the model was trained in dev or QA environments, and then somehow over time in production, it saw new data. And there's usually a big retrain button that we could push, and that would help recalibrate the model, but really only if the labels are accurate and everything's in place with that button truly work in a production scenario. So why do I think this is happening in data quality? In traditional data quality, a human goes in and decides maybe we're going to write a row count check or a null check. And as they're doing this, they're making assumptions. They're saying, I think it'll never be below or should not be below 900,000 rows. Well, ultimately, that data set is growing and it's moving away from them. It's probably becoming 1 million, and then 1.1, 1.2. And over time, that assumption or rule that they wrote is diminishing or drifting from the data set, just like it is in every other part of the analytics community. The next thing we might consider doing is writing a null check. But am I going to write 2 nulls or 2% of nulls? And we start to really think about this problem. And the second humans try to presuppose what the past was, what the future will be, we're ultimately probably writing something that's static and hard coded and isn't going to last that long. So these past experiences of picking a tool and then trying to see how many rules we could manually write, we kind of realized that even if you could write all of the rules, within 6 months or a year, many of those rules will no longer be of the same value as when they were written, and possibly not accurate at all. So they start to diminish in value of what we can do. And basically, a better approach, or an approach that we started to take years ago, is what if we could curate rules from the data itself, right? The answers in the data. A credit score probably looks and feels like a credit score. The valid range of values is likely between 200 and 850 or whatever the data suggests. But it almost becomes more about rule management than rule curation, because that is and can be done at pretty great scale at this point. But then there is variance in the data, and that variance continues, and there's jitter. And what we sort of need to do is look at the trend and baseline of the data and kind of follow it through to be able to predict where it will be in a month from now. And we call that an adaptive rule, right? So that's part of the solution to this problem, is getting comfortable with rules needing to be managed and then thinking about how that would work and how will we adapt over time to the changes in our data. We will absolutely see new schemas, new column headers, different value types. We absolutely see the row counts change, the null values change, and even the business desires change over time. So we need something that can live and grow with our data sets and evolve over time. And we find that to be pretty much critical. And I would argue if we catch ourselves writing static rules or starting yet another project, we really need to take a step back and think, am I just recreating the same problems that I likely had in the last project? Or am I going to end up in that 80-20 scenario again? Versus having a mechanism that could not only curate, manage, but then evolve with the data sets. That's going to be much more manageable if we could get that right. So the second really interesting topic of the traditional data quality world is being reactive. You know, if we play a day in the life of scenario, something always goes wrong. It's hard to know what would possibly go wrong tomorrow, but something will go wrong. And usually the analyst or end user is the one that catches it first. It's the one that's looking at the bar charts or looking at the data and saying, this cannot be true, that my house can't be worth $0 anymore. Or, you know, and then they find out that once the listing is sold, the item's cleared, and all these nuances can happen, but we end up being unhappy with the data. And then that means we're unhappy with the business and the accuracy of the analytics. So what can we do, I guess, to be less reactive? Traditionally, we would race back to the team and say, let me add another piece of logic. Let me think of another way to write a 300th rule for this scenario. And then the next day we'll kind of trip and fall until we catch up with ourselves. So we don't want it. We need to get out of that cascading effect and try to forecast and be more predictive about what tomorrow will bring. And we can do that with learning from past trends. And we can do that by trying to test assumptions ahead of time. So in many cases, we're looking at a row of a database or file or at a column level, and then we're stress testing it from many different angles. And we're asking it things that maybe we wouldn't have a thought to ask, but not just nulls, not just empties, not just distribution of values, but correlations and associations and all of these things. And when those tests and assumptions don't play out the way they used to in the past, that is an interesting trap that we can protect ourselves from in the future. So we do know at this point that with enough change detection and behavioral analytics, and with the scale of where computing power is, especially with GPUs in the cloud and clusters of servers, that we absolutely can run massive what-if analysis and testing our assumptions from every different angle and get ahead of this problem. And that's been just an incredibly exciting area, one that we recently issued a patent in and that we just continue to invest in, that has just been remarkable for what we're going to be able to do automatically and then also be kind of forecasting those answers. And why that part becomes so important is this concept of explainable AI. This is another looming concept, right? That's just been out there for far too long. And with explainable AI, we're all of us, including myself, we're dubious of the black box. We're dubious of the model. Okay, it found this interesting finding, fantastic, but I don't trust it. I don't know how it derived at this finding, and I can't explain it to my boss or my team or my manager, and definitely not the regulators. And where this leads us to all the time is it's just the first step to test more assumptions and be more predictive. You have to be able to explain it. So in our modern solution, for quite some time, if we identify an interesting finding of this nature, and we can predict what the correct value would be, it's also the obligation of that routine to go back and figure out how it got there. And what I mean by that is we don't just show break records, right? We can't just show an erroneous piece of data. We have to surround that piece of data with good data. That gives us context. It helps our human brains say, I could see it was good, good, good. It fit into these categories, and now it's wrong. And all of a sudden, you know, in the 5-second test, this can finally start to make sense to us. So many times, you know, I myself am looking at something and I can't really see the value in the prediction. I know it discovered it for some compelling reason. And whenever we dive into it, we know that it's usually accurate, and it was a really strange event. It was anomalous, and it predicted us the right answer. That part's great. But if I can't see that whole path, that lineage of events that led from good to bad, I also am not able to action it quick enough. And, you know, my brain moves on, so to speak. And as an analyst, I have to go look at another one on the list. So ultimately, we need the ability to be predictive instead of reactive. But with that comes a lot of work that we've kind of had a journey through over the last 2 or 3 years, where now when we make predictions, we also need enough visuals and enough description to be explainable. And so I think explainable will remain as a key point to help the analyst move through this change detection. And, you know, it can sort of start to help us with the whole, can I sleep at night factor? It's very hard to know the unknown, but with the right scale and the right solution built around that scale, and with the right compute power and testing all of these data assumptions, we can get much closer, at least, to starting to think about, okay, I have a lot of coverage. Most of the time, what we're talking about in data is, you know, what are my scores? What is my health? And that's important, but ultimately I really need to make sure I have coverage before I could ever feel comfortable with that scenario. So here I'm going to kind of draw out, I think, another huge flaw fundamentally of the way managing data and data profiling and data quality has been done largely in the past of traditional data quality. We would start a project much like what's on the screen here, where maybe we pick a simple metric such as row count, and we're going to measure it over time, over the days. So we go off and we profile the data. And we come back with a single point, which is, I guess, on the screen here, presented on, you know, day 4, and it looks like about 15 rows. And we know that we have a profile of this data set. But we have a prescriptive approach that we fundamentally believe is the right way to do data profiling and data sketches. And it has to be over time. It has to be in the rhythm in which the data was ingested. Or what happens is this dot can become far less meaningful. And what I'll show here is if I sort of play out what really happened in the rhythm in which this data was loaded, it looks more like this. And this is the true picture. This is part of the kind of the core ethos of the fundamental design of replayability, testing those scenarios and watching data play out over time. We can see here that really on day 3, we have an interesting event where maybe it's outside the normal range. We first had to learn that range to make any sense of the data at all, but likely that event on day 3 really needs to be labeled. It needs to automatically be labeled as either non-productive if we follow the machine learning codes, or just false or outside of the normal baseline, or in traditional words, a break record or an alert. And we need to figure out if that is normal and acceptable or not. And an analyst could opt in to this way of thinking and start to just tag things with feedback loops. And what that helps us to do is really understand the true flow of data and where it will be tomorrow. You know, we might expect that the range of valid rows would be between 15 and 30, or maybe between 15 and even 35, the way this data is moving. But 1 row or 0 rows is not going to be okay in this particular scenario. And you can see where we would fall victim to that. So many times we start projects and people say, I want to take a profile for the last year, or I want to take all of last month and create a data profile. I would say strongly to try out a replay feature, much like what we support in our solution, and actually just use the slider and replay the data across the last month or across the last year. That's how you're going to see all the changes that have happened to the business, all the metrics that have changed, and that's how you'll be able to forecast what will happen tomorrow. And in a single point in time just doesn't solve that problem. Another kind of key component is data ownership. So, we're all a bunch of, or myself could be labeled as a data nerd, and I would prefer to be called a data geek. So I think it's much cooler. So everyone can join me united as data citizens and geeks that care so much about data, as you can see from how much time we take just considering data profiles and sketches. But in the past, we had things such as, are you allowed to have access to the data? But that's really roles and permissions. So I'm going to have access to a lot of data, and that's great. But what are the data sets that I should govern or maintain or own? And meaning, if I could get to a world, and I'd argue that we've achieved it in our modern data quality solution, to where I could generate so many rules, I have the coverage, and I'm getting more comfortable with the way that coverage and scoring works. What I still haven't solved for would be, who does it go to and who has to take action? And it's interesting when you think about it. So once again, why do we have this 80-20 problem at all major organizations? Well, we know whose job it is to load data. There may be an ETL developer or someone that has been put in that role. We know who the database admin is. Those roles are well defined at large organizations. But does anybody define whose job it is to make sure the data is accurate and to make sure that you can trust it? And that's probably part of the missing link as well. So with a strong data ownership model, Collibra has been good at this for a long time and has really understood this well. You can understand and opt in and out and finally start to create a self-service model where the software plays a role and delegates to who should care about the data set when it's wrong. You're ultimately going to be in a place where you have enough data, laws of large numbers, where things are breaking and also very successful every day, but you'll have your set of issues. And if you're in charge of making sure every issue could possibly have an alert mechanism, we would kick that can only one step further down the road. Or if every issue or break record sits in a bucket and waits for someone to care, that's also going to be tough, I think, to action these and get to resolution. But with a strong data ownership model, you can automatically send the right data break records and data errors to the people that care the most about that data set. And this helps us kind of placate into and personify what we're trying to do with a real data governance, data intelligence solution, right? Which is to have everyone care about the pieces that they should care about, so to speak, or be managing. So I think, it's just the start to be able to auto curate rules, and it's a good second line to be able to manage them and have them adapt with your data sets over time. But until we get to data ownership, which is the mission that we're sort of integrating with and working on with the combination of total DQ and data governance coming together, then I think you have a hard time reaching a full self-service DQ and DG program, which is the final frontier that we're sort of seeing become the separation of roles and responsibilities to ownership and stewardship. So another reason I think that it's been, a large challenge for businesses to have accurate and trusted data all the time is we have rules in place, and we get more and more of them in place as time goes on, but we have to rank sort them. And it's very hard to prioritize depending on how you've built your rules and what your scoring system really looks like. So if I have 100 emails in my inbox, it becomes difficult for me to know which one, if I only had time to read one or two, that I could read today. So what we have found is you really need several key things to be able to operationalize a data quality program. Just having a tool where then you trust that all your users are going to write as many rules as they can, and that they happen to write the right ones, and that they're going to take action, and then they're also going to take action in the right rank sorted order, is a really big assumption. And what we would suggest is nearest in time is very important. So let's play that out for a bit. You're going to have columns that have always had some nulls. But then what if last night a column that has never been null becomes 50% null? Well, I could probably live with all the other columns that have had some level of nulls or empties, meaning they're incomplete and we're missing data. And that's scary to think about, but it is the reality. And we're going to have a hard time getting to 100% accuracy ever, right? So we're just going to try to do the best we can from a reasonable standpoint. But I need to definitely know if I'm about to experience an event in my business that I've never experienced before. So a steep change in something that has happened is the level of egregiousness. And that's the score if we're doing kind of a natural data science way to score. And then we need to really think about, and it just happened last night, while we were sleeping. Well, that's scary because we don't know what the impact of that is going to be on us today. So nearest in time, egregiousness of score, the count of the number of issues that has happened, if it happened across the board in many cases, say we went to a 0 row count in 5 data sets. Well, that's interesting. Clearly an entire process dropped out on us, right? From a data ops perspective. And then ultimately we use a graph engine and now connected to Collibra's lineage tool, which is a better graph engine to compute how many downstream data assets does it impact? Because without impact analysis, it could be a null that I don't care so much about and I have too many other things to do. Or I have a list of 100 breaks and I really need to be able to rank sort what to do today. So from an operational perspective, I would say, and maybe get people to challenge and think about, even if you had enough rules, and even if your program was in place, could you take action through a workflow each day and resolve them? I think having the ability to be able to prioritize and rank and sort is really the answer to that. And the other thing that we can do as we become total data intelligence in a more modern world is start to leverage the critical data elements and start to leverage all that human analyst knowledge that has been put into something like a data catalog that we can glean from and say, I know this element is also more important to me. That's another way to help me rank the prioritization of the things that could go wrong. It's also a way to help me just clear the list for things that I may not be able to spend time on every day, because we'd like to get to everything, but there is a practicality to this approach. So the final challenge, I think, at least for this session, to dive into is bespoke data quality. The more organizations that I met with and had talks with and kind of evaluated what they were doing in many cases of the space, they were treating files differently from tables or Kafka messages or JSON objects or files separately from CSV files, or potentially writing their own Python scripts that leave them open to scoring however they like. So I could say that, hey, to me, this sounded important, so I gave it 10 points. Somebody else in a similar scenario only gave it 1 point or 2 points. And this creates bifurcation, and it doesn't unify the problem. It sort of slows down this ability to create a single mesh of a solution or a software that could scale across your organization. And it also has us doing, some awkward things. So ultimately what we really want to be doing is, use something like a Spark data frame or a data set. And that gives us a unified way to look at files and tables and Kafka messages. It also helps us with scale, because if we're really going to do this to achieve that coverage, we need to think about how much compute we can do. On my particular team, we've achieved 10 million cells per second. And we're going to keep raising that bar, but we can kind of debate how good or bad that performance is. I think it's pretty awesome compared to maybe where it would have been years ago with things like Spark 3, GPUs, ephemeral compute. We don't even need the compute up all the time, right? But that becomes part of this challenge. How can I apply that same rule that I wrote on a file, and will it work on a database table, and will it work on a Kafka topic in real time? Well, it does. That's here, right? That's part of a modern approach, and it really needs to be, because it's the only way I can manage a global rules library where I have certified and trusted rules and trusted results that can scale horizontally and not tap out. The other thing I think that becomes really hard too, if you don't take this approach, is how do you get to roll up reports? How do we ever feel confident that one lake is managed the same way as another lake, or that this group of users and files? In the traditional world, just writing no rules would actually give you 100. I would say your coverage is 0. And so distribution and scale plays a role in becoming a unified solution and less bespoke. At the end of the day, I've had a great time sharing at least some of our experience and journey, but I empower each person today, to think about how you're going to make a difference this year, for your organization, and how are you going to create more trust, more accuracy, more coverage, and make a difference in the brand and franchise and what they feel and trust each night, right? And how they can service their customers. And I invite anyone to reach out to myself or team, and I'll be happy to share more details on our journey and what we're doing around this area. Thank you. And I appreciate the time.